In part 2, we talked about latitudinal variation in biomes, but we can substitute latitude with elevation if we have big mountainous regions like we do here along the Wasatch Front. So we can see through an increase in elevation a substitute for the patterns that we might have seen as we changed latitude and looked at the vegetation in different climatic zones. So here's a picture taken from Big Cottonwood Canyon. For those of you that have hiked this part of Big Cottonwood Canyon in the Wasatch, you know this is the road taking you up to Donut Falls. It turns out it's also a fully glaciated basin, and this basin right here is also fully glaciated. In fact, this here is the terminal moraine, or what's left of the terminal moraine. So let's look at vegetation gradients here in the Wasatch Front. Here's an aerial depiction of the Great Salt Lake Valley, and then the Wasatch behind it. This would be Heber, Park City, then moving on to the Uintas. This is Utah Valley to the south, in the transverse range right here. As we drive up any of the canyons, and here I'm showing you a picture of Big Cottonwood Canyon, we're going to see a change in the vegetation which is present. If you have a guidebook out, or if you know the vegetation, what you'll notice is that as you leave the Salt Lake Valley and go into any of the canyons, what you'll first see are gamble oak on the edges of the canyon. This is the vegetation we see immediately behind the University of Utah campus. We have these deciduous shrubs, Quercus gambleri, the gamble oak. Above them, we'll find that the oaks are replaced by the Utah juniper, Juniperus osteosperma, which is then quickly replaced by a series of coniferous forest species. White fir, Abies concolor, which is then replaced by Douglas fir, Pseudotsuga menziesii, which is then replaced by subalpine fir, Abies lasiocarpa, and then we see the introduction of Engelmann spruce and limber pine at the highest elevations. So over a gradient where we end up at the top at 3,000 meters or go down to 1,600 meters, we're going to see the replacement of a half a dozen or more species along precipitation and temperature declines associated with the change in elevation. Now, the vegetation change you see with elevation on the front side of a mountain range need not be exactly the same as you see on the south side or on the dry side of a range. That's because of a rain shadow effect. Here if this is the Wasatch Mountains, here on the west side where most of our storms come from, precipitation is wrung out as the clouds move over that mountain range. As the air descends down into Park City, you see that there's less precipitation at any elevation. So that if we were to draw distribution limits for each species, we would see that on the dry side, the Park City side of the mountain range, the lower distribution limit of a species is higher in elevation than it is on the west or front range side of the Wasatch Mountains.